Stars rarely form alone. Instead, they tend to be born in groups called star clusters. But why does this happen? What causes stars to form in clusters rather than as solitary objects scattered across space? To understand this, we need to explore the journey of star formation, a fascinating story that begins in vast clouds of gas and dust known as nebulae. Nebulae are enormous regions in space, often hundreds of light years across, composed mostly of hydrogen gas, along with dust particles and other elements. These clouds are the birthplaces of stars. However, these clouds are not smooth and uniform. They are turbulent and filled with regions of varying density and temperature. Some parts are denser and colder, while others are thinner and warmer. Inside these nebulae, gravity plays the most important role. Gravity pulls gas and dust particles towards each other. When enough material collects in a particular spot, the force of gravity causes that region to collapse inward. This collapse creates a dense core that gradually becomes hotter and hotter. Eventually, this core will ignite nuclear fusion, the process that powers stars. However, because the nebulae are so vast and turbulent, this collapse does not happen in just one spot. Instead, multiple dense pockets within the cloud collapse at roughly the same time. This leads to the simultaneous formation of many stars in close proximity. These groups of stars born together within the same nebula are what we call star clusters. There are two main types of star clusters: open clusters and globular clusters. Open clusters are groups of a few hundred to a few thousand stars, loosely bound by gravity. These clusters are usually young, ranging in age from a few million to a few billion years. Because their gravitational bonds are weaker, open clusters gradually disperse over time as stars drift away. Open clusters are often found in the spiral arms of galaxies, including our own Milky Way. In contrast, globular clusters are much larger and older. They can contain hundreds of thousands, sometimes millions, of stars packed densely into a spherical shape. Globular clusters are among the oldest known objects in the universe, often more than 10 billion years old. Their dense gravitational pull holds the stars tightly together, preventing them from dispersing over billions of years. These clusters orbit the center of galaxies in a spherical halo. So the question remains, why do stars form in clusters rather than individually? The answer lies in the physics of the nebulae themselves. Nebulae are not uniform clouds, but turbulent environments with complex motions. The gas and dust inside these clouds move around, creating shock waves and compressions that cause the gas to clump in some regions. When these clumps become dense enough, gravity causes them to collapse into stars. Because the cloud fragments into many such dense regions, many stars form nearly simultaneously in the same general area. This is more efficient than stars forming one by one in isolation. The clustered star formation process is driven by the physics of gas dynamics and gravity working together. Moreover, these stars remain gravitationally bound to each other after they form, at least for a time. Their shared origin means they have similar ages and chemical compositions. Over time, the mutual gravitational attraction keeps them near each other, forming a cluster. Star clusters have important roles in astronomy. Because all the stars in a cluster formed roughly at the same time and from the same material, astronomers can study clusters to learn about stellar evolution. By comparing stars of different masses in the same cluster, scientists can better understand how stars change over time. Clusters also offer insights into the history of our galaxy. Globular clusters, being very old, provide clues about the early conditions of the Milky Way and other galaxies. Open clusters help trace the recent star formation history in galactic spiral arms. The clustered birth of stars also affects the environment around them. Massive young stars and clusters emit strong ultraviolet light and powerful stellar winds. These energetic processes can blow away remaining gas and dust, influence the formation of new stars, and shape the structure of the nebula. In some cases, interactions between stars in dense clusters can lead to interesting phenomena, like close binary systems or even star collisions and mergers. These events can create unusual objects like blue stragglers, stars that appear younger than the rest of their cluster. In summary, stars form in clusters because they are born in giant, turbulent clouds of gas and dust that fragment into many dense pockets simultaneously. Gravity pulls these pockets inward, creating multiple stars near each other at the same time. The stars remain bound by gravity, forming groups known as star clusters. Understanding star clusters helps us learn not only about star formation, but also about the history and evolution of galaxies. When you look up at a sparkling cluster of stars in the night sky, you are witnessing the beautiful, natural outcome of the cosmic forces shaping our universe.